Can you expand on the ways that you require your students to graph linear equations? Some tabling and then graphing, along with why you infuse vertical and horizontal lines throughout.
Well, those are two good questions. And the first one is actually kind of massive in scope. I could spend a whole hour actually explaining my thoughts on graphing, if you will. But really, it's more my thoughts on what is algebra and how do you get kids to start thinking algebraically. I found in my first couple of years of teaching, when I taught graphing as, hey, plug some numbers in, or hey, put your pencil here, move it up 2 and move it over 3 and connect the dots. In the end, students really hadn't learned anything, and they would get confused then by quadratic functions, some more advanced graphing issue. So I tried to come up with a different way of approaching graphing where it was contextualized into this bigger idea of relationships. And when I say relationships, I mean this driving question of as one number changes, what happens to the other one? So when we get all the way to graphing, we're just answering that question visually. We're providing pairs of numbers that give us concrete examples of as one number increases, what happens to the other one. So you'll never see and Get More Math sort of rise over run thinking, for example, because that just produces the graph, but it doesn't really get kids thinking about the relationship itself. Instead, you'll see a whole lot of problems designed to gradually entice kids' brains into a deeper and deeper understanding of relationships as a set of pairs of numbers, which themselves are sort of dynamic. They're produced over time, perhaps, or over some other driving factor on the x axis. When you actually work problems out in your graphing and Get More Math, you'll often have kids required to fill in a table, and that's to keep them grounded in the reality of the relationship, to make sure they get that the relationship is made out of pairs of numbers. You'll also notice that after a while, sometimes the table will stop appearing. And that's designed to, in a way, to remove the scaffolding. So you don't want to always have them be given all the sort of things to fill in and then produce the graph. At some point, you want to just be like, here's the thing, graph it. So that should give the kind of the baseline philosophy of how I teach graphing. You also had the kind of the corollary question, why vertical and horizontal mixed in there? Well, one of my early observations, again, basically, Robbie, this whole conversation is going to be like, here's the thing I did wrong or did suboptimally. It didn't work well, and so I changed it. Because in my first years, that wasn't the case. Those were unique sort of set aside skills. And what I found was kids just completely lost those ideas within days of learning them. Any algebra teacher who's listening to me will understand what I'm about to say, and nobody else will. But if you have a day where you're learning to graph horizontal and vertical lines, so you say graph x equals 2, and you say graph y equals 3, and the students learn what the desired output is. Oh, y equals 3 looks like this. X equals 2 looks like this. I'm not making it up. The next day, if you say graph x equals 2, over half of them will do the y equals thing instead of the x equals thing. It has to do with what the axes are named and the fact that within 24 hours they've forgotten the rationale and they slip up. Like 80% of them will get it backwards. So I wanted some way to attack that. And in my system, if you integrate from the beginning those two kind of unique cases as just another way to form a whole bunch of pairs of numbers, another way to think of make a table of a set of pairs of numbers and then represent them on the graph, instead of their own kind of special stand aside siloed thing, but rather integrated into everything else. For my students, they were never this weird other thing. They were always just one of the many ways to graph a relationship. Although technically the x equals weren't a relationship. And we won't go into that, but math is full of technicalities.